Good day to all viewers. Today in this video, we're gonna show you how to design for production of sunflower seed. First, where did sunflower seed came from? Sunflower seed came from sunflowers, which the scientific name is Helianthus annus. I think they are large plants and are grown throughout the world because of their relatively short growing season. And as we all know, the sunflower seed is commonly eaten as snack by consumers on all around the world. In this video, we will show how to design the fludization, pneumatic transport, and the hopper design for the sunflower seed. Before we show how to design, the most important thing to know is the properties of sunflower seed. According to Goldad's classification of particle, sunflower seed was categorized as group D particle, and the particle usually have 600 micrometer of diameter and typically have high particle densities. If you want to know more about the Goldad's classification of particle, you guys can Google it.
From the storage, the sunflower seed will be transported to the fluidization bed to undergo the fluidization process. The purpose of the fluidization process is to separate the different size of sunflower seed. Generally, there are three types of sunflower seed, which is large, medium, and small. The only size that is used for the conventional purpose is the large sunflower seed, which is range of 6 to 8 millimeter. On the other hand, the fluidization process also used for the heating process. For the production of the sunflower seed, the heating process will be undergo at the temperature of 150 degrees Celsius. In the fluidization process, the seed need to be transported out the bed is the small and medium sized seed. The large seed will be stay in the bed and will be transported to the pneumatic process. However, there is a rule need to be obeyed. As stated in the slide, the rule need to be obeyed to undergo the fluidization process is U0 must be lower than UMF and must be lower than the terminal velocity. In order to ensure that the large sunflower seed will not be transported out, the value of U0, UMF and terminal velocity is calculated for the large seed. By taking the average diameter of large sunflower seed, 6.77 mm, and the medium of fluidization is air, the value of U0, UMF and VT is calculated. To calculate the value of UO, the equation for incompressible fluid is used. First of all, we need to calculate the value of delta P over H, voltage and DSV. After that, the value can be substituted into the equation. Then by using mathematical method, the value of UO can be obtained. Next, we need to calculate the value of UMF. Because the diameter particle is 6.77 mm, which is more than 100 micrometer, we use the Van Der equation to find the value of UMF. In order to use the Van Der equation, first we must find the value of Archimedes number. Then substitute into the Van Der equation. Next, we calculate the value of terminal velocity Vt. In order to find the value of Reynolds number RET, we must first need to calculate the value of CD RET square. Because the value of CD RET square is too big, which is out of the range on the graph, we must find the value of RET square by using another correlation. From the RET square, we can find the Vt. The value of Vt is then compared to the value of UO and UMF calculated. From the result, it can be seen that the value of UO is less than UMF and less than Vt. Hence, it obeys the rule of the design. The calculated Vt is based on the diameter of large particle. So for the production of sunflower seed, the value of Vt is higher than UMF and U0. so the particle can be entrained out of the fluidization bed. However, the calculated VT is based on large particle. It indicates that the velocity required to entrain the large particle is equal to the value of VT. Hence, in order to entrain the small and medium-sized particle, the velocity required must be less than the VT.
Continue with the pneumatic transport. Pneumatic transport basically using gas to transport a particulate solid through a pipeline. Gases have been used successfully in industry to transport a wide range of particulate solids. Most pneumatic transport was done in dilute suspension using large volumes of air at high velocity. Advantage of dense phase transport is low air requirements, generally means a lower energy requirement. Resulting low solids velocities mean that product degradation by iteration and pipeline erosion are not major problems. In this pneumatic transport, the value of total pressure drop through pipeline are important because this value will be used to compare with the maximum allowable pressure in pipe based on its diameter. So total pressure drop are sum of value of pressure drop in pipe are horizontal and vertical, and also pressure drop at pipes bends. These are all the equations for calculate the pressure drop in pipe. Equation number 1 and 2 is pressure drop due to the gas acceleration and also particle acceleration. Next, equation number 3 and 4 about pressure drop due to gas and solid wall friction. Meanwhile, equation number 5 and 6 calculate the pressure drop due to static head of the solid and static head of the gas. To calculate pressure drop in horizontal pipe, using only equation 1, 2, 3 and 4 because there is no static head value in the horizontal pipe. These are some extra formula needed to find certain value in the equation number 4. Next, calculate pressure drop at the vertical pipe by using equation number 3, 4, 5 and 6. Equation number 1 and 2 can be neglected because gas and solid are already iterated in the line. Pressure drop for bends. To calculate pressure drop for bends, it by using this simple equation. In spite of considerable amount of research into bend pressure drop, there is no reliable method of predicting accurate bend pressure drops other than by experiment for the actual condition expected. In industrial practice, bend pressure drop is often approximated by assuming that it's equivalent to approximately 7.5 meter of vertical section pressure drop. In this absence of any reliable correlation to predict bend pressure drop, this crude method is probably as reliable and as conservative as any. Thus, the equation as follows.
Now, we move on to the last part of the design, which is the hopper design. The purpose of the hopper is to store the particle in the storage container. To design the hopper, first, we must calculate the values of unconfined yield stress, which is sigma y, and compacting stress, sigma c, and the value of effective angle of internal friction, which is delta, in the Morse circle. The Morse circle should be drawn tangent to the yield locus. If the graph have many yield locus, pairs of value of sigma y and sigma c are found from each yield locus. As the graph shown below, it shows how to find the effective angle of internal friction, which is delta, by plotting the effective yield locus line. Next, we calculate the value of the kinematic angle of friction between powder and hopper wall, which is sigma w. Omega w can be calculated by using the formula below. Another way to calculate the omega w is by using wall yield locus. By using wall yield locus, you can find the omega w. By using the value of omega w and delta, we can obtain the hopper flow factor, which is ff, and semi-included angle of conical hopper wall slope, which is theta value. Is shown as the figure below. It is usual to allow a safety margin of 3 degree, which means the value of theta you get need to minus by 3. Then the value you intersect with the omega w is the ff value. Then we find the value of sigma critical. The table above is obtained from the family yield loci that we get earlier. Then, the table below was obtained from the formula of sigma c over ff equal to sigma y. With these two tables, we plot a graph of sigma c versus sigma y, and the line that intersect is the value of sigma critical. And lastly, we calculate the value of the minimum diameter of the conical hopper outlet, which is B, as shown as the formula below. After you obtain the value of the minimum diameter of the conical hopper outlet, you need to design the hopper yourself. But the value of the diameter of the conical hopper outlet should exceed the minimum. So, this is how the design for production of sunflower seed was calculated. Before we end this video, we're gonna show you some of the product from sunflower seed. Hope you enjoy. Thank you.